Here's problem 12:18. The diagrams below show forces applied to a wheel that weighs 20 newtons. The symbol W stands for the weight. In which diagrams is the wheel in equilibrium? For anything to be in equilibrium, we must have that the summation of the forces in all directions equals 0. So that would be true in the x direction, y direction, and so forth and so on, z direction, or any direction you choose. Also, it must be true that all the torques about an axis perpendicular to this plane, z direction in this case, would also add up to 0. So for equilibrium, we want all these to apply for an xy plane as we have set up here. So as we look at these four examples, so look at the first example, we have a 20 Newton force going vertically here, and the weight force is also 20 newtons going down. So those are canceling in the y direction. So there is no y net force, but we have these two forces going in the x direction. So there is a net force on this object. There is a net force in the x direction equal to a total of 20 newtons. So we don't have no net force. We also can consider the torque. We have a torque that is going counterclockwise with a radius r and a 10 Newton force, and that would be a positive torque. So this one would be a positive torque of Rf coming out of the page. And then we have another torque going clockwise, and that would be a negative torque. So that one would be into the page, same Rf. So the summation of all the torques about this origin is actually equal to 0. So that is equilibrium, but we don't have equilibrium due to this net force in the x direction. Alright, so let's look at the next problem. This one we have a 20 Newton force going up and a weight force going down, and hence they cancel out in terms of force. We have a 10 Newton force going to the right and a 10 Newton force going to the left. So the summation of all of our forces, either x or y, is going to be 0. So our net force is actually 0 in all directions. That's good. Well, we have a torque that's going clockwise here as we're trying to go around this way, and hence that would be a torque that is into the page of magnitude r times f. We also have another torque that's also going clockwise, and that would be into the page as well if we use the right hand rule, and that would be of magnitude Rf. So the summation of all of our torques about the origin is actually going to equal r times f plus r times f into the page. So we could say a negative r times f plus a negative r times f is a negative 2rf is our net torque into the page. And since we have a net torque, this is not in equilibrium. Whew. Alright, let's look at the next example. We have two 10 Newton forces going up, and then we have this 20 Newton weight force going down. So the summation of all the forces in the y direction is going to be equal to 20 minus 20, or 0. And there is no forces in the x direction, so force equilibrium exists. What about torque equilibrium? We have no net torque due to this central force because it has no moment arm. We do have a moment arm for this 10 Newton force on the right, making this rotate counterclockwise, giving us a net torque out of the page of r times f. And then for this one on the left, it's going clockwise, giving us, by the right hand rule, a net torque going into the page and magnitude Rf. So our net torque is going to equal a negative RF for the one into the page plus a RF for the one out of the page, which is going to be 0. So we have no net torque on this one as well. So no net force, no net torque. This example is in equilibrium, so we choose answer C. Let's look at D just to be complete. We have a 10 Newton force going up and a 10 Newton force going down plus the weight force of 20 newtons. So the net force in the y direction is actually going to equal 10 minus 30 or a negative 20 newtons. In other words, in the j direction. If we look at that as a vector. So we do have a net force. The summation of the forces in the x direction would be 0, but we do have a net force in the y direction, and we do have a net torque because this torque going around is going to give us a positive RF, and this other torque also going counterclockwise will also give us a torque coming out of the page equal to RF. So the summation of our torques is going to be RF plus RF, 2RF. We have a net torque as well, so this is definitely not in equilibrium. So our only answer is C.